So now we're looking at probability 27B, and we're looking at a scenario where we have a person shooting free throws in a basketball game. And in this case, he's fouled and he gets 2 free throws. And a lot of times with free throw shooters, they sort of, based on their previous work, we can kind of know how often they make free throws. And so in this case, we're saying that Frazier, who's our person shooting free throws, makes them about 4/5 of the time, 4 out of every 5 shots he makes. So we want to determine the chances of him making different amounts of points, like scoring 2 points or 1 point or not scoring at all. So I'm going to go right back to a tree diagram. Always are helpful in these cases. And so I'm going to do in this case that he hits the free throw or he misses the free throw. So those are my abbreviations: hit or miss, or makes it or doesn't make it in this case. But in this case, we hit the free throw or we miss the free throw. And it says he has a 4/5 chance of making a free throw, which means he has a 1/5 chance of missing it. So that's the first shot, and he gets 2 shots in this case. The second time, he can either hit or miss. And if he missed the first one, he still gets a chance to make another one. And so our probabilities don't change in this case: 4/5 and 1/5 that he hits or misses. 4/5, 1/5 that he hits or misses. So let's look at the different things that can happen here. We can either hit them both, hit one and miss one, miss the first one, hit the second one, or miss them both. And the probabilities of each, we just follow the different lines. So we have 4/5 times 4/5 for hit, which is 16 out of 25. For hit miss, 4/5 times 1/5, and that's 4 out of 25. And then miss and then hit, 1/5 times 4/5, or 4 out of 25. And then miss them both, 1/5 times 1/5, or 1 out of 25. So there's our different possible things that could happen when he gets 2 free throws and the probabilities that they will happen in each case. So if we look at the questions, what's the probability that he's going to score 2 points? Well, that's this one here. 2 points is 18 out of 25. And these are actually really nice and easy to change to percents, because if I want to find that out of 100, I just multiply times 4. And so that's 64 out of 100, or 64% of the time we would expect that he scores 2 points. There's 2 situations where he scores 1 point, which is the hit-miss or the miss-and-hit. So we're going to put those 2 together. 4/25 and 4/25. I'm going to put them together. Equals 8/25. Again, we can make that into a percent real easily by multiplying both the top and the bottom by 4. It comes out to 32% of the time that he will score 1 point. And then the last one in this part is that he will not score at all. And that, of course, is just our last one here, 1 out of 25. Again, I can make that into a percent by multiplying by 4, top and bottom. And so 4% of the time he doesn't score at all, if his free throw shooting percentage is around 80%, which is what 4/5 represents. And so that's how we could determine most likely to score 2 points, but could score, and maybe one of the questions is what's his likelihood of scoring a point, any points, and it looks like it's about a 96. If you're a 4/5 or 80% free throw shooter and you get 2 shots, 96% of the time you have a chance of making some points. Only 4% of the time do you not score. So that's pretty good. Well, what happens when, see, in some basketball games you don't get 2 shots, you get what's called a 1 and 1. So if you make the first one, you get to take a second shot. So that kind of changes a lot of our probabilities. He's still a 4/5 shooter, but getting to shoot the second shot depends on making the first one. So our tree diagram is going to be a little bit different. We're going to start with the hit or miss on the first shot, and that's 4/5, 1/5. But if you miss the first shot, you don't get to take another shot, so this branch is done. If you make the shot, you get another chance. And there's your probabilities, 4/5 and 1/5. And so now you really only have 3 scenarios. You can either hit them both, and that's 4/5 times 4/5, or 16 25ths, or 64 100ths. So he still has 64% chance of hitting both, getting 2 points. It doesn't change because we still have 4/5 times 1/5, and that gives me 4 out of 25, or 16 out of 100, or 16% of the time. But then this branch just ends, and so this scenario is just simply miss, which is 1/5 of the time he misses. And again, I can change that into a fraction out of 100. 1/5 times 20, so it's 20% of the time that you have that situation. So now we can answer these last questions on this section. So what's the probability he'll score 2 points? Well, that hasn't changed. It's still 16 out of 25, or 64 out of 100, or 64% of the time he's going to score 2 points. That he'll score 1 point now is only 4 out of 25, or 16 out of 100, or 16% of the time. And that he will not score, that's the last one. If we look on our tree diagram, that he will not score is this 20 out of 100, 1/5, or 20% of the time. So the 1-in-1 situation sort of lowers his chances a little bit. Before, he only 4% of the time would not score. In this case now it raises it to 20% of the time. His overall percentage or opportunity to score is actually at 80% in a 1-in-1 situation, where it's 96% when he gets 2 shots. So having that extra shot really helps increase his percentage or likelihood of scoring points in this case. But again, difference is the diagram changes because this branch ends once he misses the shot, whereas in our other example he gets to take that second shot down here and either hit or miss. So you have more opportunities with a two-shot foul shot as opposed to a 1-in-1.